Hey there, everyone. My name is Ryan Schul. Welcome to my data science channel. So in the topic today, I want to analyze and forecast microeconomic trends and macroeconomic trends. So micro is small, macro is big. You'll see how this stuff plays out in just a minute. Let me just take a quick second to introduce you to the data sources. So I'm getting my Fred data from here. You can sign up. Takes less than 60 seconds. This is the Fred API. I love these APIs because you can just make a fetch to the API and pull back the data. If your data source is something static, like you have to download a CSV file or an Excel file, it's just more work, right? You have to download the file, save it someplace, network drive, or to your local PC or something like that, and then you have to point your Jupyter Notebook to that source and then import the data. If it comes from a live feed like this, or like this is the microeconomic data on this side. This is the micro. Okay. Once you sign up for an API, you can just fetch it. The data comes out quarterly. So when the new data is available, just click a button or just refresh the cell and everything comes in, right? That's why I like these APIs. It's pretty dynamic, pretty live. And this is quarterly data. So it's not like you're doing this every day or every week. Not even every month, once every 3 months. But it's still more convenient just to go fetch the data from the API, pull it back, and you're done, rather than saving down a couple of files or a whole bunch of files, and then you have to point your Jupyter Notebook to that and then ingest the data that way. So I think just API interfaces are very useful and very helpful. So you can go ahead and sign up for a free account here. This is the macro data, this is the micro data, and let's get going. Okay, so I'm doing the macro data first. So I will put that over here. I'm just going to switch this around. Forecast macro trends, okay, macroeconomic trends and microeconomic trends using Python. Okay, so just rename the notebook here. So why do we even want to analyze or forecast macro trends and micro trends? Like, what's the point of that? Why are we even doing this exercise? Why does it make sense? Basically, macro trends are big picture, what's happening in the entire economy. Is the economy shrinking? Is it expanding? Are inflation and interest rates under control, or are they spiraling out of control? What is the overall state of employment in the entire country, right? So big picture, big things like that. Micro trends are more zoomed in, more focused. Micro focuses more on specific sectors, businesses, consumers, labor and economics, industry trends, consumer behavior, targeted marketing, and product strategy. Okay, so again, macro is big picture, big GDP, CPI, consumer price index, interest rates for the entire country. And this helps us to make informed strategic planning decisions. Microeconomics, on the other hand, is more anticipating subsectors, sector level, helping forecasting, inventory planning, HR planning, pricing strategies, things like this. Okay, so remember, macro is big picture, micro is little picture. So I put together some code for us right here. Okay, pretty standard matplotlib. I'm not even going to use that. That probably came in from something else. So we have, just to ignore the warnings in the Jupyter Notebook. Sometimes you have these warnings pop up. It's not mission critical. It's not going to stop you from doing your work, but it looks a little bit weird. So I like to turn those off. I'm getting Fred data from here, and this is my pandas data frame. So most of the things you'll do in the data science world revolve around pandas and SciPy. SciPy library, use those all the time, but there's at this point, there's so many libraries, I think 100,000 or something like that. Let me do a quick Google search. I looked at this recently, but this changes all the time. How many libraries? Python. You see that? How many libraries in the US? You see that? 137K. Okay, so that's a lot of libraries, guys. That's a lot. So that's a lot, but a lot of times you use just a handful of pandas, and SciPy are pretty frequent. So when you sign up for your Fred API key, when you go over here, get your key, it takes about 60 seconds to sign up. You pop that in here. I'm not going to refresh the cell because I can't expose my key, right? I don't want that on the internet. This is personal and confidential. You never share your keys with anybody. So I'm not going to refresh the cells, but I did this earlier today, and I'll step you through all the all the work that I did and take you through all the effort that went into this. So we have a series dictionary, GDP, quarterly billions, unemployment rate, CPI, that's the consumer price index, federal funds rate, that's the interest rate that banks lend to other banks, right? That's like the baseline interest rate, and 10-year treasury rate. So this is the rate that you would earn if you invested in 10-year treasuries as a fixed income investment, right? So we pull all that into a pandas data frame and go down here, and we'll have the quarterly GDP, unemployment rate. So this should match, right? If you look over here, unemployment rate, CPI is next, CPI, and the last two are federal funds rate and 10-year treasuries, federal funds, 10-year treasuries, okay? So we're in a good spot. We have all our information. Going back to 1954 for the macro data, and then the most recent was January 1st, 2025. Now it is June 26th, 2025. So with these federal agencies, this is certainly not live data. You can tell it's not even updated monthly. They are at this point in time about 6 months behind. I think you'll see a new report coming out very soon. This is why I like to work with these APIs. As soon as the data is available, you go fetch it and you already have it, right? But there is quite a lag. It's government data, it's quarterly reporting, and there's really no motivation on their end to do it more frequently. I think it just doesn't matter. It's so big and so cumbersome. This is a behemoth, but like, would it make any difference if you collected daily or monthly data or weekly data? I think it would be a huge lift, and it would be a big ask for these guys because so much goes into this, so much analysis and refinement goes in. I think it takes a whole quarter just to produce the results, right? So let's move down here. So we have data coming in 2025-0101. So I realized this when I was putting the code together yesterday. When we get to the micro side, the data looks very different. So everything is cut off at the end of 30. So if the month end is 30, like here you have March 31st is actually the last day of the month. But for the micro data, it's cut off at 3:30, right? So if I show you my calendar, go over here, go back to March. So you see there's 31 days in March, right? But they cut it off at 3:30. So we have to get these dates to match up. And I think September is the same. If I go to September, no, 30. So what was the other one? It was, December, right? So December has 31 days. But if you look close, they cut it off at 12:30, right? So we have to get these dates to match. So I put in a couple extra lines of code just to refine the data slightly so it does match, right? So we don't want stuff like this coming in the beginning of the month, the first day of the month. We want to convert that to the last day of the month and truncate that at the 30th day of the month, okay? So I have DF index, PD date time, just to convert that into an actual date time. Make sure it's an actual date time. We're looking at quarterly data. Timestamp has to be Q, and we're going to normalize the data, and we're going to say macro index, set this to the macro data frame. This is the macro data frame. That's why I assigned it over here. If you look closely, we have the original data coming in here, and I assigned data to macro data frame. And you see the head and the tail and the shape, 283 rows, 5 columns. So hopefully that makes sense. And we're just saying if lambda, if day equals 31, use date, and D is going to be 30. Okay, so D replace 30. If day is 31, like the last day of December is the 31st, the last day of the March is the 31st. If day equals 31, convert to 30, and then you'll see everything is month end, and that matches what we're going to see in the micro data in just a minute. See, so the 1231 is concatenated or truncated, and the March 31st is truncated to the 30th. So now we're in a good spot. Now we can move forward. So I'm going to look at the microeconomic data. The macro is all cleaned up. It was pretty easy to fetch that and to get that in a good state. So I want the micro data now. So the big picture macro data is done. We're going to fetch the micro data. We are getting that from a different source. This comes from this API. This is called BEA. Okay, and this is the what the heck is this? Business Bureau of Economic Analysis or something. I forgot. It's just flashing that one way. Bureau of Economic Analysis. Okay, so the API is here. API data is here. You sign up to get a free account. It takes about 60 seconds. So from here, we're going to get GDP, consumer spending, income and savings, all the industries that exist in the United States, international trade and investment, prices and inflation, and then employment by state. Okay, so this is going to give us, sorry, I need a cold water break. This is going to give us all of the employment records and unemployment and so on and so forth at the state level. So I had to look this up, doing a little Google searching and a little bit of, what's that called? Chat GPT to get this. So this comes in like a dictionary format. If you go down here, you'll see the format down here. So here's the dictionary. You can tell this is the key right here, and these are the value pairs, and you can tell by the curly braces. So this is a whole bunch of data frames embedded inside of dictionaries based on the key value pairs of each one. We have to go ahead and extract that into a normalized data frame. So once we do that, it's going to be a lot easier to work with. So I say for each label and value, it's like doing two loops at the same time, two levels of looping in all data. All data comes from here. If you look above, there's the all data. So we set a dictionary just to capture the dictionary. We're going to import that into another dictionary. We're going to print all the labels and do all the extraction. Once we get that into all data, we're going to put everything into a list. So you can tell this is a list by the square brackets. This is a dictionary because of the curly brackets, right? You'll have three primary types of data. Lists, actually four. Lists I use all the time. Data frames I use all the time. Dictionaries, I'm starting to use a little bit more. These key value pairs, I realize are very useful. There's another data type called a tuple. I don't use tuples very much. I guess there's a time and a place for it, but I don't really tend to use those. But anyways, we're going to create a data frame. I'm going to create a label and append all of the data frames based on the category of the label to this label. And we're going to concatenate everything together, ignore index, and then create a final data frame. And the final data frame looks like this. So we have 18,708 rows and 11 columns. These are the columns: table name, series name, line number, line description, time period, metric, CL unit, data value, note reference, and category. Okay, so you can see kind of a lot of work to get this going, but once it's set up and working, it's going to be very easy to interact with this data. So the goal now is to accomplish the following tasks. We want to clean and extract the relevant data. So we started doing that. It's in a good state now. Pivot for analysis. Okay. And then we're going to convert everything to a time series format because everything here is changing over time. If you look closely, we start in 2000 Q1, 2000 Q2, Q3, Q4, Q5, Q4, Q1, 2000, then up to 2023, 2024, Q1, Q2, Q3, Q4, and it's cut off here. Now it's June, end of June 2025. Again, this macro data is a little bit like the micro. There's kind of a lag. There's like a 6-month lag here. I'm sure it's a lot of work. I'm not putting anyone under the bus here. I'm sure it's a lot of work to aggregate and to collect all this information from all these vast resources. So it takes a while to collect this, do the aggregation, and do the reporting. So yeah, you're not going to get real-time data, not even like weekly or monthly lag. This is 1 month lag, and sometimes it's 6 months, right? Because we're in the middle of 2025 now. So convert everything to time series, merge to the existing data, and make forecasts. And we'll forecast, and first we're going to analyze and forecast next. Analyze. Okay, so that looks good. Making some updates to my notes as we go. So anything that needs to be cleaned up or needs to be forced into some type of quarterly format, we're going to handle that with this. So anyone in the first quarter is going to be ending with 03, 2 is 06, 3 is 09, and 4 is 012, just to match what we had in the first data set. So when we combine all these and aggregate everything together, everything has to match at some level, right? So we can, like you saw before, we had month end 1231 and 331. We have to convert those to 1230 and 330 to get everything to match up, because we're going to merge everything based on the dates. This is the only thing that these data frames have in common. So we're going to extract the date here and then use that as an index to merge this micro data to this macro data, which already has the date. So this is a little bit more convenient to access, right? They have that date. But again, this needs to be cleaned up too, because we have 01, the beginning of the month, and over here with the micro data, we have, which one was it? Oh, yeah, over here. So with this one, we have quarter end, which is fine, but we just have to have everything in the same relative scale so we can do the merging downstream. Okay, so now we're looking in the microdata GDP, consumption, income, and prices, and we're going to go ahead and do, based on these categories, category 1, 2, 3, 4, and 5 actually didn't exist. I was looking for these, but they didn't exist in the data set, so something changed, or for some reason it used to be there, it's not there anymore, or maybe that part of the system wasn't reporting correctly. I'm not sure, but there was originally 6 categories. But you can see we jumped from 3 to 6 because 4 and 5 just didn't exist when I did this analysis late in the day yesterday. So maybe there's a bug, maybe some server went down. I don't know, but it wasn't there when I was looking for it. So I just skipped those. So now we get everything from GDP to consumption to income to prices, and we're going to merge everything together. So we have consumption and GDP. We're going to do a merge on date and an outer merge. So an outer merge will combine everything. Even if records don't match up, they're still pulled in so we don't miss anything. If you do an inner merge, you only merge based on what matches. Okay, so I think the outer merge makes sense. Grab everything if it exists, and we'll clean it up later. If you do an inner merge, it might be appropriate in some cases. Actually, in many cases, it is. But if there's not a match between the two data frames, you're dropping records, right? And you can do a left merge or an outer merge. Typically, I like it. You can do a left or a right. Typically, I work with outers or inners, okay? So here's consumption. We're merging that to GDP. You can see that right there. We have micro DF. So now we have micro DF. We're merging that with income. So this is the fourth data frame. Again, assign everything to micro DF. So we have micro DF down here. And then we have prices. And again, assign everything to micro DF. So we took these four data frames, GDP, data frame 1, consumption is data frame 2, income is data frame 3, prices data frame 4, get everything unified into one single data frame, and we end up with this. GDP billions, consumer spending, real GDP, and GDP price index. So that's the head, this is the tail, right? Going back to 2000, beginning of 2000, and ending in 2024. So it's March, June, September, and December. Okay, so everything is in a good state now. We can move forward. So we have micro and macro. We are going to make sure that the index, which is the date, if you look closely, these dates are the index. So anything in the left-hand side of the data frame is an index. You can see this is kind of like one level below. So this is kind of like the parent level. This is the child level, only because this is an index. If this date was at the same level, if it was raised up a little bit here, the GDP, then the index would be the count of the rows. So 0, 1, 2, 3, 4, 5. So that is one way to do an index. I think this is just a little bit more intuitive because we're merging on dates. We can set the date as the index, okay? So we just are converting everything. Make sure everything is the time and the date. It should be, just for peace of mind. We're going to make sure. We're going to do an inner merge now just to pick up everything that matches. And this is the micro DF. That's what we see right here. The macro DF was the first example. Here's the full DF sort. And this is what we have when everything is amalgamated together. So we have outer, ensures no data is lost, right? So everything in the whole universe is merged together. Anything that doesn't have a match, you'll see a NaN. This is not a number. That's not a number. Or we can use an inner match. I think this is better in this case. We have 100 quarters of data going back from the end of 2024 until the beginning of 2020. I think we have enough data here to do a pretty comprehensive analysis. So now we have GDP and unemployment, CPI, federal funds rate, 10-year treasuries, right? That's what we saw from the macro data. Now we also have GDP billions, consumer spending, go down here, GDP billions, consumer spending, real GDP and GDP price index, real GDP and GDP price index. So everything on the right-hand side is micro data, everything on the left-hand side is macro data, and everything is matched up based on the date. And then we have all the data inside the data frame right here, okay? This is the head on the top, this is the tail on the bottom. So now we're in a good spot, right? We're about halfway through, and should warn you guys, this one is kind of a marathon teaching lesson here, but stick with me. I think the outcome is going to be worth the time that you put into it. So we have GDP billions. We're going to convert this into a percentage change and look at this quarter over quarter, similar to consumer spending in billions. We're looking for a percent change multiplied by 100, and consumer price index percent change multiplied by 100. This will give us consumer quarter over quarter change, inflation quarter over quarter percent, quarter over quarter percent, and quarter over quarter percent. So then we can actually get the real GDP billions. Again, the percent change gives us the year over year percent, and the unemployment rate percent gives us the unemployment change, and everything is appended to the data frame. So you can see we finished over here with GDP price index. It's GDP, real GDP, change billions, GDP price index. So you see that, change billions, price index, and we created these new columns over here. So this is what these 5 lines of code does right here. So quarter over quarter, GDP quarter over quarter, consumer quarter over quarter, percent inflation quarter over quarter, that matches that. All right, so that's number 3. Real GDP year over year percent and unemployment change. Okay, so now we have all the analytics that we need to go ahead and do a plot. We can plot all of this data. We're going to look at GDP quarter over quarter percent, consumer quarter over quarter percent change, inflation quarter over quarter, real GDP year over year, and unemployment change right there. Going back to 2000, we can see the percentage changes, kind of stays within the band, 5% to negative 5%, kind of consistent and persistent until we hit COVID over here. Then everything gets wackadoodle, right? So we have some major changes up here, 10% unemployment rate, and then negative 10% for what this is. Let me zoom out here. The red is consumer price, consumer spending. Okay. I love these plotly charts because you can click here and activate the chart, right? And pick exactly what you want to look at and focus just on that, right? So if you just want to look at CPI inflation, you can see the scale here goes up to a little over 2 and down to negative 2. If you add in unemployment, it's a whole different scale, right? It goes up to about 11.2% unemployment and then negative 4.6 unemployment after the government stimulus checks started to come in and people started getting back to work. Then everything became more normalized, right? So this COVID data is very interesting, and you can see what an impact it had on the macro factors here, right? So feature engineering for ML forecasting is pretty easy too. We can use GDP billions, consumer spending billions, and unemployment rate in percent, and look at a shift to look at the lag. So shift 1 is lag back in time 1, shift 2 is lag back in time 2, and shift 4 is back 4 periods. Remember, this is all quarterly data. So shift 1 is like, we'll take everything for GDP billions, year spending billions, and unemployment billions, and go back 1 quarter. This goes back 2, and this goes back 1 year, which is 4 quarters. Okay, you can see that over here. So the lags are introduced over here. And at the beginning, you see 1 year lag or 1 quarter lag. This is 2 quarter lag, 1, 2, 3, 4. So the lag shows up over here, right? Because we're going lag 4 back in time. So let's look at the plot over here. I'm not going to get into all the details here, but the features are going to be unemployment rate lag 1, 2, and 3. I'm using Plotly charts. I've got several videos on my channel about how Plotly works. It's actually very easy. The x-axis is the data frame index, and the y is the data frame column, right? So the columns are over here. It's on the top of the data frame, and the index is on the side. These are the dates, right? So we can see here the macro and microeconomic trends. We have unemployment, lag 1, 2, and 4. So they're pretty consistent. They kind of follow just with a slight lag, whether it's 1 month, 1 quarter or 2 quarters or 4 quarters, right? And what I like about these Plotly charts too, it's very interactive. If you look at this bit of code here, slider control gives you the ability to slide the slider back and forth and zoom in just on specific time periods within your data if that is your objective, right? So we can pull the chart in this way, we can pull the slider in that way, and then we can focus on just the COVID piece of the data, right? And see what kind of impact that had on micro and macro economics. And then of course, if we want to pull the slider apart, we can see the entire universe of data and everything that's been happening here. So you can see there was some unemployment spikes around 2005, went down around 2010, it spiked up. That was probably due to the 2008 financial crisis, right? And the repercussions from that. And then we steadily declined until COVID. Then we had another crisis. So it seems like there's always some type of crisis. The dot-com crisis of 2000, 2008 financial crisis. Now we have the COVID crisis. So I'll be looking forward to the next crisis. It's just not enough for me, guys. It's just not enough. I'm just kidding. I'm tired of all these crises, but you can't get away from it, right? There's nothing you can do. It's a very dynamic environment. So let's do some forecasting. We'll prepare data with lag features. We're going to look at one feature, GDP billions. If you go back over here, you'll see that GDP quarterly billions. So this is the first feature in the data frame. So I'm going to go ahead and add some lags, 1, 2, 3, and 4. And anything that's an NA, I'm going to drop that. Any kind of NA is not existing data. I don't think we had too many, but it's good to get rid of these things. And some models, an NA will throw an error and the whole model blows up. Some models are a little bit more forgiving and it'll just ignore the NAs. But it's good practice if you have NAs to drop those, because a NA is not a number or a NaN, and it's not going to help you. And there's nothing to report if you have that kind of thing too, right? So we're going to look at three types of time series models. We're going to look at a random forest regressor. So I'm calling the random forest regressor model right here. I'm setting the target variable as, where's my target? Let me see, target. Okay, here is GDP billions. That's a target. And I'm looking at, I'm letting all the other columns be inputs to try to help me determine what is the statistical impact on the target variable. So this is the target, but based on that, I want to see which of these columns over here are going to have an impact, a statistical impact on the target, okay? So I'm picking this as a dependent variable, and all these other columns are the independent variable. So independent of what happens, nothing is going to change an independent variable, but those independent variables can have an impact on the dependent variable, right? So that's the target, and we're setting that right here. This is the target. Independent variables are everything else. So there's my random forest regressor. I'm going to try an XGBoost regressor. Again, training and testing on the data. Train and test is over here. So I'm splitting it with 80% training base. So 80% of the data is used for training. 20% is the holdout. That is used for testing. So that's my second time series model. And the third is going to be profit. This was created by the crew at Facebook. So profit will help us based on the date and a target variable Y. The target variable right here, Y is the GDP. All right. If you go back here, GDP in billions, that's what we're trying to predict based on all the independent variables. So I'm looking at the R squared and the adjusted R squared for each of these. So when I run this, I see random forest R squared is negative 1.776 and the R squared, adjusted R squared is negative 2.51. So basically useless. Like you want an R squared of at least 0.70 or higher, positive. Anything below 0.70 really doesn't have a high statistical impact on the target variable. And the negative R squared will basically be useless. Now, I forgot why R squared can be negative, but you would think anything that's squared is positive, right? Like negative 2 squared becomes a 4, negative 10 squared becomes 100, but R squared, negative R squared is possible. You see that, I think, because they're not taking the number and then squaring it. They're taking all the R squared and then taking the series of that. My understanding is R squared cannot be negative, okay? But it can. So that's normally true. While you answer this question, R squared is the fit of the chosen model with a horizontal straight line. R squared is not always a square of anything, so it can have a negative value without violating any rules. R squared is negative only when the chosen model does not follow the trend of the data, so it's worse than a horizontal line. Okay, so that's the answer, right? So you can have R squared if the GDP is continuously going up. We would expect the R squared to go up. In this case, it's probably trending down just because the model can't capture the nuances or the way that the data changes over time, right? So it is trying to calculate an R squared. It's struggling quite a bit, and it's actually saying it's negative R squared. XGBoost is saying negative R squared 1.6. So that is basically useless. But profit comes to the rescue, right? Positive 0.9962. So we're going to go with profit as a model to go ahead and make forecasts into the future, right? This is a time series tool. The other two are regression tools. You can use it for time series. Regression is not true time series. A lot of times Random Forest regressor or XGBoost regressor performs quite well. In this case, it's really falling on its face. It's not able to predict anything. So I'm going to look at the Y target variable, right? And then the Y hat. So that's the change. And we're using profit forecast. You can see the actual number and the profit forecast. If I zoom in a little bit, you can see it's making a forecast now. So we're in the end of June 2025. So here comes the forecast. And if you zoom out just a little bit, the blue line is the actual and the red is the forecast. So the actual stops right here, December 30th. That's when the actual date stops. Profit kind of dips down a little bit. I think there's a slight gap. I don't think it should really be doing that, but whatever. There's a disconnect. But after that, after a couple of days, it picks up and understands the trend. It's up to the right. Now we're in the middle of June or end of June 2025. So right about here, which is fine. And profit is smart enough to be able to forecast into the future. So this number is hard to read. 30 billion or 30 trillion. What kind of number are we looking at here? 30 billion, I think. In billions. Oh, trillion. Okay. So 30 trillion and up to the right. So that's where we are. And it's saying by the end of 2026, we'll have 32 trillion GDP. Okay. So gross domestic product. This is all the goods and services produced by the United States and I think consumed either abroad or in the United States and abroad. How is Gross domestic product is a comprehensive measure of a country's economic activity. It represents total market value of all final goods and services produced within a country's borders. Yep. In a specific period, usually 1 year or 1 quarter. GDP can be calculated using 3 approaches: expenditure approach, income approach, or production approach. Okay, so it's everything produced within the borders of a country. It's not, that doesn't have anything to do with trades or tariffs. It's just all the goods and services produced in the United States. So we can go ahead and we already made the forecast into the future. We can go ahead and look at the y-hat lower, y-hat upper. This is going to give us a confidence interval or a range. So the y-hat is what we're trying to predict, and the ds is the date. So it's actually very simple. You only have 2 points here. The date is on the horizontal x-axis, and the y-hat is on the vertical axis. So this is the GDP that we're predicting, and this is the time period of that prediction. Okay, so I thought the graph was rendered. It was not. So this is profit with confidence intervals. Let's go back to 2023. Zoom in a little bit. You can see the data stops at the end of 2024, so December 2024. But we have actual numbers in black. The forecast is in blue. That's what we saw before. The difference in this case is that we have an upper and lower bound. So we have confidence intervals because we don't know exactly if it's going to be, what is it, 32.92 million, right? But it could be a little bit higher, could be a little bit lower. That's why we have the confidence intervals, right? So going on here, we have the actual predictions. So right now it is just about 6/30/2025. So this is actual. This is the y-hat. This is the y-hat lower. We expect the prediction of GDP to be that. The y-hat upper could be as high as 309, low as 301. We expect it to be 305. Then September, December, end of this year, we expect 310 for the GDP, 306 lower, 314. By September 30, 2026, so that's about 15 months out, we would expect the GDP to 392, 324 on the low end, and 333 on the high end. So that's the forecast, right? So I will leave it to you guys to do repeating tests for consumer spending and billions, unemployment rate, and real GDP. If we go back here, consumer spending, unemployment, and real GDP, you'll see here, unemployment and consumer spending. And then where's real GDP? Right here, okay? So same type of analysis. All you would have to do is put in the lags. You wouldn't even have to change that. All you'd have to do is change this over here, GDP billions, okay, and rerun the analysis. I'm not going to do it because we're already 32 minutes into the video. I don't want this to drag on to be an entire day, but I think it would be a worthwhile exercise for you guys to try that. Plug those in, rerun the analysis, and see what the output is for those different macro variables, and some of these are micro variables. Remember, we blended everything together. So what do we have at this point? A train test split using lag features. We used Random Forest regressor, XGBoost regressor. Both of those fell down flat on their face, but profit performed pretty well, 0.99% R squared, so, or 0.99 R squared, right? So highly accurate in terms of predictive capabilities. Forecast using Random Forest, XGBoost, and profit, R squared and adjusted to R squared. Profit forecasted printed, and that is this right here. That's forecasted printed out, and profit forecasted visualized. That is right here. I like to put, make these charts a little bit different. Not different, but consistent. So now we have a little bit broader and a little bit wider, and I think it's a little bit more pronounced. So that looks good. I'll do the same thing over here. A little bit lazy, so I don't want to type it out. I'm going to copy and paste. And I think that looks good. That should work. Let me see. Okay, got it. So I'm going to save this right here, guys, and I'm going to wrap up the video at this point. I'll share all the source code with you guys, like always, and I'll post this Jupyter notebook, saved as an HTML file. I will save it right now. And I'll share this file with you when I post the video a little bit later today. So keep an eye out for that. And I'll see you guys in the next video, okay? Take care for now, and I'll talk to you soon. Goodbye.